Hello everyone, this is Kalpana working as an assistant professor in SNS College of Technology at Artificial Intelligence and Data Science Department. Today we are going to discuss about recurrence relation. So next, with the help of basic operation, I am mentioning this m is nothing but multiplication. M of n is equal to m of n minus 1 plus 1, which means just consider 5 into 4 factorial I told. Okay, this 4 factorial is nothing but it can be written as n minus 1. Correct? If n is 5, it can be written as n minus 1. So, m of n minus 1. These many multiplications I need plus 1 multiplication, which is nothing but this one, into 5. This 4 factorial require n minus 1 multiplications plus this n, I need to multiply n minus 1 with the n. Okay, so 1 plus 1 multiplication required. So how many? M of n minus 1 plus 1 multiplication. This I have written like this. For n is greater than 0. If n is equal to 0, it returns 1. So we need to set up the recurrence relation for this. And when n equal to 0, m of 0 is equal to 0. No multiplication is going to happen. We are going to end the we are going to end that algorithm. So here we'll apply backward substitution to derive the order of growth, whether it is n square n or 2 power n. We have studied the order of growth, no? So with the help of backward substitution, we are going to identify this. How can we do? M of n is equal to m of n minus 1 plus 1. Okay. M of n minus 1, m of n minus, m of n equal to m of n minus 1 plus 1. Okay, this is the equation we had with the help of basic operation. So we need to substitute this in backward, like this is my first equation. For m of n minus 1, again I need to substitute the value. That is, if I give m of n is m of n minus 1. And what about m of n minus 1? If you add minus 1 here, it becomes m of n minus 2 plus 1. So m of n minus 2 plus 1. This is for m of n minus 1 plus 1 is already there. So plus 1. Okay. So likewise, I am going to substitute for m of n minus 2. For m of n minus 2 is what? M of n minus 2 minus 1. So which is nothing but m of n minus 3 plus 1. Correct? Again one 2 is there. So if I add, I will get 3. M of n minus 3 plus 3. Okay, so like this I have to derive the equation. And here, if I see m of n, so I am starting from minus 1, n minus 1, 2, 3 until n equal to 0. When I get m of 0, till where I have to stop, if I get the answer, if I reach 1, there I can stop my execution. So I have to end with the help of, I have to end this thing if I get m of 0. Okay, m of 0. So here, if you substitute I, m of n minus I plus I, m of n minus n plus n. So m of n minus n is 0 plus n. Okay, finally you will get m of 0 equal to what? 0 only. So 0 plus n remains the same. So m of n is n. So here the order of growth is order of big O of n, you can say. So for factorial, finding a factorial of a number using recursive fashion, it requires order of n times. The time complexity is order of n. Okay, so like this we need to carry on. Thank you. And just consider calculating factorial of a number. We can write a factorial algorithm with the help of an recursive or else with the help of a non-recursive fashion also we can write this factorial algorithm. We'll see how it can be done with the help of a recursive algorithm, recursive manner. So just consider a factorial. If I want to calculate factorial for 5, okay, I need to calculate factorial for 5 factorial. What I will do, so I have to multiply 5 into 4 into 3 into 2 into 1. Correct? So like this I have to multiply the numbers till I get 1. From 5 to 1 I have to multiply all the numbers, then only I will get factorial as 120, 5 factorial. So this can be written as 5 into 5 minus 1 factorial. Am I right? 5 minus 1 factorial. So this factorial can be written as 5 into 5 minus 1 factorial. When I am going to calculate factorial for 5, I can write 5 into 5 minus 1. 5 minus 1 is what? 4. 4 factorial. So the number 5 into 4 factorial is what? I can write this 4 factorial as 4 into 3 into 2 into 1. So finally I am going to get 120. So why I am doing this thing 5 into 4 factorial, 5 into 4 minus 1, because I am going to calculate factorial in a recursive manner. With the help of a single operation, I am going to perform this factorial. Repeatedly, I am going to multiply this thing. So, for doing that, I am deriving this 5 into 5 minus 1. If you want to generalize this statement, I can write as n into n minus 1 factorial. Correct? N into n minus 1 factorial. Okay. So if I want to convert this into a recursive function, what I can do? So this is the recursive function for factorial. This is function f of n. So inside that, if n is equal to 0, that is 0, it returns 1. Okay. If n value is 0, it returns 1. Else, I am going to calculate f of n minus 1 into n factorial. That's what we have done here, n into n minus 1. So n minus 1 into n. So I am going to calculate this f of n minus 1. I am going to call this function recursively. This f is nothing but the function name. Here I have given f. If you have given factorial, as per your wish, you can give whatever the name you want. So the same can be given here, fact of n minus 1. So n minus 1 times I am going to call this function recursively, okay, into n. So this is the function I am going to write for calculating factorial in a recursive manner. So let's decide on the parameters. First we need to identify the input size. So here we have given n itself as an indicator, that is input size is n here. Next, the basic operation we need to identify. What operation I am doing? Always see here 5 into 4 into 3 into 2 into 1. So here also multiplication symbol alone is there, right? So repeatedly what I am doing is I am just multiplying the multiplying the numbers till I reach 1. Okay, so the basic operation of this algorithm is nothing but multiplication. Okay, so how many times this multiplication is being executed? N times. So if you see, n times the multiplication is being executed. Okay, I can write this function as f of n minus 1 into n. Okay, the same function we have written here now. The same is written here.